We are going to continue. This is 3.3 section, but I'm going to talk a little bit more about this hierarchy of data types and talk about why it says it's ranked by the largest number they can hold. Okay. I did a Google search for the size of operator, and there's a sample code. This is out on Tutorials Point, which is another good website to use, and I'm just going to copy that code over, and we're going to run this in our JDoodle just to see what we get. So there is what's called the size of operator, and we execute that. It's going to return the number of bytes that an item will hold. So for example, if I also just kind of Google number of bytes in a character, and I Google that. So if I take a look at what this says, how many bits or bytes are there in a character, and this is another website that you should start to get familiar with a little bit. It's called Stack Overflow, and people will post a question and then other people will respond to it. So be careful when you're using this, because the question that gets posted here is usually some code that's wrong and somebody's trying to fix it, and then you can find the solutions down below. So here's our answer. It depends what is the character and the encoding. So the encoding is important. We're going to assume kind of ASCII coding right now. So 1 byte, which is what we saw was returned by a character, is going to be 8 bits, and that's what the reference that we're going to use. Different types of encoding are used in different countries and on different different computers that have a different processors, like a 16-bit processor versus a 32-bit processor, etc. And so if you get into working with data files, you'll notice that a lot of them are coded in what's UTF-8 or UTF-16, etc. We're not going to worry about that. What we want to know is that 1 byte is going to equal 8 bits, and when we use the size of operator, it's returning a byte. So this is telling me that a character takes up 1 byte. And 1 byte consists of, quote, 8 bits. And we could get into that more, but we're not going to right now. But look at these descriptors in front of what I want you to look at is, oh, sorry there. The first one was a char, a character. The next one's an integer. So an integer takes up 2 bytes. But then we can take a short int, or we could have a long int. And it says a short int is 2 and a long int is 8, and actually it doesn't show me the size of the int on this. I'm going to hit execute again. There we go. So int, short int, long int, these words short and long can be applied to not only integers, but they could also be applied to doubles. So when we go back to that chart on our hierarchy here, when it says long double, what that means is that it's going to increase the size of memory that that variable can hold. And so this hierarchy here is from the lowest up to the highest. An unsigned int is basically an integer that doesn't have any negatives assigned to it. I don't know if our example has unsigned int in there or not, but we could put that in there and see what it does. If I have an unsigned integer, what kind of space does that take up, etc. If I execute that, a regular integer is 4 bytes, an unsigned int is 4 bytes. So that doesn't change anything there as an example. And so why that might be important is if you're really needing to worry about space on a machine, and also to understand how this hierarchy chart works. I can create, well, the other thing is double versus float. That's one question that we often get. What's the difference between a float and a double? Well, a float takes up 4 and a double takes up a space of 8. So a double is literally twice as much memory available as a float. And then I could do a long double if I copy this line right here, Control C, so that specifier, that long double, if I do long in here, can be used on both integers and on doubles. So a long double is going to be 16, etc. I have no idea what a wchar_t is, but it has a size of 4 bytes, whatever that is. Okay, so that lets you understand a little bit about how that hierarchy works. When it's talking about the largest number that they can hold, they're talking about the size of that. The rest of these slides I think we just kind of talked about a little bit. And we talked about casting. And there is some more kind of when we talked about casting using a char. Okay. That's going to wrap it up for this particular slide right now. We might want to pay attention to these two though. This is something I should have addressed in the other video. So if you listen in, fill in your colleagues in class, please. But on this particular program, if I take area divided by 500 and I do this calculation, no matter what that calculation is, whether it's a double or an integer, if I cast it to an integer, it's going to be changed. The whole calculation will be changed to an integer. Versus the second one down here, static cast double sum, that only changes sum to a double. And then we have divide by count. And so what that does is I have double division divided by integer division, and so the type coercion changes the whole thing to double, and that's assigned to average. So the second one calculates as we would expect. This first one might not, because I cast the whole calculation to an integer. It's going to change that answer to an integer and then assign it to gallons. Now if gallons is an integer, it stays. If gallons is a double, it still stays as an integer. It's just represented as 4.0 as an example. That wraps up, or should wrap up, the section. One more slide, I guess. I didn't talk about this because this is the old way to do casting, which some of you might be familiar with this. But it's actually not used anymore in C++, or it shouldn't be. It's the older. You might see it, but it's not used as much, and so I just didn't even mention it. And if I go to the next slide, we are done with that section.